This lesson is identifying proportional relationships. This is really one of the foundational lessons for 7th grade math. It's really truly foundational because it does set you up for 8th grade. It's actually the beginning of your linear algebra studies. So kind of pay close attention here and make sure that you're understanding what's going on. If you look up here in this box, it's a little key concepts. So in a proportion, when one quantity increases, the other also increases. So for example, if I went to Rita's and I bought one regular ice for $3, if I bought 2 regular ices, I would assume that they're going to be $6. If I bought 3 regular ices, they should be $9 then because they're each $3. That's what happens in a proportional relationship. If I told you I got 2 candy bars for $3, I would get 4 candy bars for $6. So that's what's actually happening in a proportional relationship. We're going to use this vocabulary word. So the constant of the proportion or the constant of the proportionality is the unit rate, and we're going to call that K in this case. And the relationship, if it is proportional, forms an equation y equals kx. So if one is going up at the same rate as the other, we're going to actually end up being able to write an equation in this part of the chapter. So a scientist recorded data collected by a rover sent to the planet Mars. The scientist recorded the time it took the rover to travel to several different distances. So time in seconds, distance in centimeters. We have a table here. Anytime we have a table that's set up top and bottom like this, you are, unless it's labeled otherwise, allowed to make the assumption that x is on the top and y is on the bottom. That's standard practice in math. If you have a table that looks like a T-chart, which you're used to seeing from before, you have, unless it's labeled otherwise, the ability to assume in math that the x would be on the left and the y would be on the right. So what we're going to do is we're going to actually calculate the constant of proportionality here, which is the value k, and we do that by doing y divided by x. So in this first one here, I'm going to do 10 divided by 2, and I actually get 5. In this next one, my y value is 30, my x value is 6, so 30 divided by 6, which is 5. In the next one, I'm going to do 15 divided by 3, which is 5, 45 divided by 9, which is 5, and 20 divided by 4, which is 5. So, what we actually find out here is that our k value is 5, and that ratio tells us how many centimeters the distance that the rover has traveled per second. So if our k value is 5, we can basically write this equation, y equals blank x. And in that blank spot is where we're going to plug in what k was. And k we just found to be 5. So that tells me that this has a proportional relationship because all the k values were exactly the same. So in this case, the k value was 5. My equation is y equals 5x. Yes, this was proportional. If one of these k values turned out to be 4, this would no longer be proportional because the k values all have to be the same for every single piece of data in order for a relationship to be proportional. Take a look at the next example. The number of bracelets that Reese can make in X hours is represented by the equation y equals 3/4 x. So, complete the table of values below. Notice this is X hours and Y bracelets. So if X is 1, 3/4 times 1, she's going to be able to make 3/4 of a bracelet. In 2 for X, 3/4 times 2, that's going to be 1 1/2. In 3, we're going to be able to make 2.25 or 2 1/4 bracelets. And in 4 hours, she's going to be able to make 3. So, calculate the constant of proportionality. We don't even actually have to do that here because y equals kx. So our k value, I can already tell you, is going to be 3/4. We could try it. 3/4 divided by 1, 1 1/2 divided by 2, 2 1/4 divided by 3, 3 divided by 4. We should get 3/4. This ratio, the k value, is actually telling me the bracelets per hour that Reese is making. My equation is y equals blank x. This is my k value, which is 3/4. since these were all the same, it is definitely proportional because all the k values were equal to each other. The next page, we map x values to y values. This is like a chart. Calculate the constant of proportionality. So in the first one, we have 3 divided by 9. We're going to have 4 divided by 12. We're going to have 5 divided by 15, 6 divided by 18, and 7 divided by 21. Y divided by x, y divided by x, y divided by x. Third. All these turn out to be 1/3, so my k value is 1/3, and it's proportional, yes, because they are all the same. The school dance committee purchased party favors for the school dance. Information about the purchase is shown in the table below. So items, cost, x and y. So what we can do is go ahead on through here. 5 divided by 10 is going to be 1/2. 10 divided by 20 is 1/2. 6 divided by 12 is 1/2. 8 divided by 16 is 1/2. 4 divided by 8 is 1/2. So my k value is 1/2. And this ratio tells me the cost per item. So the y label per the x label. My equation y equals blank x. K is 1/2. Since they were all the same, yes, it's proportional. Last one here, we'll fill in the first chart and we'll try it, and then I'll have you fill in the second chart and try it. In relationship A, here's your relationship. So let's just plug in 0, 1, 2, 3. So we want to do x plus 2. X is 0, so 0 plus 2, which is 2. 1 plus 2, we're just plugging in, which we get 3. 2 plus 2 is 4, and 3 plus 2 is 5. So to get our k value, we're going to have y divided by x, 2 divided by 0, 3 divided by 1, 4 divided by 2, and 5 divided by 3. This can't even happen. This is called undefined. So right away we do have an issue. You'll notice if we just keep going here though, that the k value actually turns out to be all different numbers, which means there is no k value because it is not proportional. Over here, let's use 0, 1, 2, 3 again. I'm going to have you pause the video, fill it in, and we'll be back. So if you notice in this one, we had this situation 0 over 0 again. That actually, we're going to just exclude that point when we're doing it. Looking at the rest of these, the y divided by x, you get a 2, so your k value is 2. It is proportional, and if I asked you to, you could actually say y equals 2x would be your equation.